Hello everyone, and today we're focusing on Cambridge IGCSE Mathematics, topic of number, subtopic standard form. So today we begin to look at what is standard form. So standard form is basically a particular way which we use to write very large numbers and very small numbers because we don't want to write so many zeros. Okay, so this is basically a way to go around the fact of writing so many zeros. Okay, and how we do that is basically we have two components. We have a, which is basically a number between 1 and 10, and we also have 10 to the power of n. So basically this could be 10 to the power of a positive n, and it could be a 10 to the power of a negative n also. And I will show you exactly how we write this through some examples, because just by looking at the notation, I think a lot of students get confused. So just know that the value of a has to be between 1 and 10. That is one of the most important things about standard form. So for an example, 3.2 times 10 to the power of 6 is a number in standard form. Why? Because 3.2 is between 1 and 10, and then we have 10 to the power of a number. In this case, it is 6, right? So how do we write standard form numbers into ordinary numbers? That is basically putting it in the normal form where we have hundreds and thousands, you know. So for example, if we have 4.2 times 10 to the power of 5, how do we write this in normal form? So first thing, 10 to the power of 5, you can convert it in terms of 100,000, and then we are multiplying across. So remember, this is basically 5 decimal points movement to the right. So this becomes 420,000, and it's as simple as that. You do need to know that you can enter these things into your calculator. So 4 times 10 to the power of 5, for example, you can use a bit of this calculator hack to try and put this in to work out how to get the answer as well, right? So how to enter the powers and how to enter 10 to the power of. And coming to moving from the large numbers into standard form. So for example, if you want to write 56,700,000 in standard form, you have to first find out where do you put the decimal point so that the number is between 1 and 10, right? So if I put my decimal point after the 7, then that is 567, which is too big. I can put my decimal point after the 6, but that is 56. Again, it is too big. So where should I put this decimal point so that it's ideal? Well, it has to be between 5 and 6, right? So I'm going to put it here, between 5 and 6. And when I put this between 5 and 6, now you can see that the value can be written as 5.67, and this value is between 1 and 10. So then how do I decide times 10 to the power of what number shall I have there for n? Well, from the decimal point, how many jumps does this need to take in order to become the original number that I need? Well, if I put it at 5.67, you can see that I need to do 7 jumps, and therefore the power n is going to be 7. So the way to write 56,700,000 in standard form is basically like this, as 5.67 times 10 to the power of 7. Moving on to the next example, so we can do the same thing if the number is very small. So for example, if you have 8.9 times 10 to the power of negative 9. Now see how small that number is. It is negative 9, right? So earlier when we had positive, we moved the decimal point to the right hand side. When you have a decimal, when you have a negative power, it is going to be a decimal, and so you are going to be moving your decimal point to the left hand side. So as you can see, from 8.9, I have to move that many number of times to the left hand side, and therefore the final answer is down here, right? And you can see it's quite easy to work with 8.9 times 10 to the power of negative 9 rather than work with such a decimal with so many decimal places. And that's the small easy hack that we have about standard form, and it brings us to the end of the lesson for today. Alright, on to some questions. So 5, 6, 9, 8, 4, 532 in standard form. So we're going to place the decimal point here, because then only we are getting a value which is between 1 and 10. And from here you can see that we have to make some jumps. So how many jumps are we doing? So 6, 9, 8, 4, 5, 3, 2. So that's basically 7 jumps, right? And so that is going to be 7 jumps to the right. So times 10 to the power of positive 7. So we're going to choose that answer here. Moving to the next question. So 8.3 times 10 to the power of 5 times 3.4 times 10 to the power of negative 2. So you have to multiply these two, and that is going to give us basically 28. So 8.3 times 3.4, so that's 28.22 for a start. And then we still have the 10 to the power of 5 and negative 2. So indices law says that you have to add the powers together. So this is going to become 10 to the power of 3. Now this is not in standard form, because you can see this value here is not between 1 and 10. So I'm going to change this to 2.822, and that means I have to multiply a 10 here, and that again has that 10 to the power of 3. So totally this is going to become 10 to the power of 4, which is the third answer here. Okay, and the next one is a seed weighs 2.6 kilograms. So I can convert this into standard form to make this question easier. So this is going to be 2.6. And when you're going in the negative direction, basically it is 10 to the power of, in the negative side, right? So 1, 2, 3, you're going negative 3 here. And then we have to multiply by 400, because we want to find the weight of 400 seeds. So 400 times 2.6 is 1040 kilograms. And so when you multiply that by 10 to the minus 3, this becomes 1.040. So that is solution number 2. And that brings us to the end of this session.